Okay, the next little section is going to deal with forces, and in particular it's going to deal with what are called force diagrams or free body diagrams. And what I've got here is I've got my good old metal mass hanging by a string. And I could, we could first of all talk about Newton's first law. I could say, okay, how would you describe this mass's motion? Well, it's not moving, right? It's not moving. Why not? Are there no forces acting on it? Well, that's not true. There are forces acting on it. So let's see, an object at rest will remain at rest unless acted upon by an outside unbalanced force. Well, there are forces acting on this. How do I know if they're balanced or not? Well, let's go ahead and list the forces and actually draw them using vectors, using arrows, because remember, force is a vector quantity that can be represented as an arrow. And so what I can do is I can draw my little mass here. And I can say, okay, what are the forces acting on it? Well, the Earth is pulling on it with a force that's called gravity or weight. So we got this downward force toward the center of the Earth, and we're going to call that weight. And notice that I can draw that vector as long as no matter how, I can draw it any length that I want. The longer the arrow, the greater the weight would be. So I've drawn a certain length vector here that indicates the weight of the vector. It's the force of the Earth pulling on this mass. That force we call weight. Now, what other forces are acting? Well, it turns out that the string is exerting an upward force that we call tension on this mass. And so I've got this upward force. I'm going to do it in a different color. Let's do it in, I don't know, green. So I've got this upward force acting that we call tension. Now, notice in Newton's first law, an object at rest will remain at rest unless acted upon by an outside unbalanced force. So what we have to do, essentially we want to find out the net force. And the way you get a net force is by taking those forces we've just figured out and then adding them together. Now this is something I haven't really explained before, but you can actually add vectors. The way you add vectors is you take your first vector. So again, remember we had weight. I'm just going to draw it downward. There's weight. Now, in order to add vectors, what I need to do is, once I've drawn my first vector, I take the second vector and put its tail on the tip of the first vector. So essentially what I'm going to do is I'm going to put the tail of my tension vector is going to go on the tip of the weight vector. I'm going to draw it as well. And then to find out the result, or the net, what I do is I go from the tail of the first to the tip of the second. Or essentially I'm going nowhere, right? Because the tip of my second vector is on the tail of the first vector. So it turns out these cancel each other out. I've got a certain weight downward, which is canceled by my upward tension force, and therefore the net force on the object is 0. And that is why it is not moving. An object at rest will remain at rest unless acted upon by an unbalanced outside force. Here we have outside forces, but they are balanced, and therefore my weight or my mass stays where it's at. Now, let's go ahead and take the situation where we have unbalanced forces. Remember what happens. Boom, right? Remember, what's the difference there? In my second situation, I have so to go back to my orange here. What were the forces acting? Weight and tension, correct? But when I cut the string, what happened? My tension went away, and therefore I only had one force acting. Is there a way you can balance a single force? It's kind of like trying to balance a seesaw with only one kid, right? If you only have one kid, you'll never have balance. And therefore, I had balance when I had my tension and my weight. They were like balanced kids on a seesaw. But the one kid left. And therefore, now you have an unbalanced situation. An object at rest will remain at rest unless acted upon by an outside unbalanced force. When I had the unbalanced situation, sure enough, my object went from being at rest to going into motion. It accelerated.